Hello everyone and welcome. Thanks for stopping by the poster and voiceover for our work, the Welsh Summarisation, Dataset, and Baseline Systems. This work is the output of a collaboration work by the UCREL team, the University Centre for Computer Corpus Research on Language at Lancaster University, and the Cochrane team, the National Corpus of Welsh, Contemporary Welsh. So my name is Ignatius, and I'm presenting this work on behalf of myself and my two authors, Mahmoud, Jonathan, and Don. As you can see from the poster, our work is on Welsh language, and we're basically creating tools and resources for the Welsh summarization, text summarization task. And fundamentally, what we're doing is to create articles, a set of articles, text articles, and then their summaries. Their reference summaries, that summaries, correct summaries evaluated by humans, and then build systems, which is summarization systems or tools that can generate summarization automatically to compare them. Okay, so when I'm going to talk you through the components of this poster we have here and in this talk. Okay, first, it may interest you to know that we are working on Welsh because Welsh is a minority language in the UK and Europe, spoken by over 800,000 people, about a third of all the Welsh population, and this is also increasing. Unfortunately, in terms of natural language processing or language technologies, Welsh is still considered low resource, not generally featured in many NLP conferences or works in Welsh, yet to be in the mainstream. But interestingly, the government and the stakeholders in Welsh are very interested in revitalizing the language, and hence this effort. So this work we're doing is at the heart of that. Okay. So what was the aim? Our aim when we started this project was to create a standard Welsh text summarization data set, and create Welsh summaries, reference summaries, so that when we build summarization systems, we will have benchmark summarization tasks to be able to assess or evaluate their performance. Then in addition to that, we also, in this work, produced an online freely available Welsh summarization tool. And all these things are going to be available so that people can leverage them in creating and building more enhanced and well-developed systems on summarization, and indeed other NLP, downstream NLP tasks that it can contribute to. How did we do it? Our method is basically simple. We have these 4 key steps that we took. One was that we collected text from a Wikipedia article. The basic condition is that each of the texts from the Wikipedia article will be at least 500 tokens. And we created reference summaries. Reference summaries are summaries that are considered correct, more or less, by human standard. And so we have 2 sets of reference summaries that we used, because Wikipedia that we extracted also allows us, the API allows us to extract the automatically generated Wikipedia summary for each of the articles. So we took that as well. We're not exactly sure how those were created, but we consider that our references. And then we also engaged human summarizers to summarize the text that we have collected, the articles we've collected and cleaned. And we made sure, because summarization is a very subjective process, we made sure that each of these articles are passed through at least 3 people, so that we see their views in the way they have summarized that, or what they think is right, the right summarization for each of the articles. Okay, so that's about the text and the summarizers, the summaries, different summaries. Then we build systems that can generate automatic summaries, which we call system summaries. We build systems that can generate that. And then we use basic techniques and the existing methods. For the baseline lowest level systems, we implemented the first sentence kind of summary. So what we did there is basically extract each line or the first sentence of each article. I use that as a summary, and there's a justification for that, because there's been work that prove that the first sentence usually laden with contents that will tell you what the article is about. So we also implemented other methods, the text rank and the lex rank methods at that level, baseline level. And the details for these implementations are in the paper. However, it's generally basically ranking. Both of them are using different methods to rank the sentences in each of the articles, and then sort them, pick the top ranked ones as the summary. Okay, so we layered on top of that different ways of representing the text in vector format. So basically, that will help the system that compares relationship and similarities of sentences to be able to do that. So TF-IDF is one of the common methods of doing that, which is time frequency, inverse document frequency. And then embedding models from FastTech and WNTL. WNTL is Welsh Natural Language Technology research work. So the embeddings that they produced in their works, we also took and use them in our work, combined with TF-IDF to produce top-line set of systems. Okay, and then we performed the experiments with this. Basically, what we are doing is generating automatic summaries with the system summaries we built, 6 of them, and then comparing them, evaluating them based on the benchmarks, reference summaries, like the Wikipedia summary and the human generated summaries. Okay, and the fundamental commonly used evaluation metrics for that is RUGE, which is what we use in this work. Okay, so there are interesting findings in our results. So this is result of each of our system summaries, the output, compared with the Wikipedia extracted summaries. So you see that it looks like they are doing quite well. Even the first sentence is quite high. That's because the precision score is really, really high. Each of these bars is representing the size of the summaries that we use. So the first one, the blue ones in most cases, will be about 50 tokens max. Next is 100 tokens. So in that range until we got to 250 tokens, because we were taking the initial summaries we had was not more than half of the size of the text. Okay, and then the brown one is where we do not actually put any constraints. So very long articles are likely going to get much larger summary sizes. But so you can see from here that for most of the TF-IDF based summarizers, the larger the summary size, the better the performance across the different metrics. But for the first sentence and the text rank actually perform quite well. If you increase the size of the summary, you kind of reduce the score. You can also observe that the lex rank is following the same pattern with the TF-IDF, FastTech, and WNLT. And that may be because that the similarity scoring method in both of them seem to be the same, which is cosine similarity in this case. We have a similar kind of result in comparing the human summaries, now not the one from the API, comparing the human summaries with the system-generated summaries. These results are poorer than this. They are poorer than this. That's because you do not expect to see. So the Wikipedia extracted summaries are likely using some kind of extractive summarization technique, which is what most of our systems use, or indeed all of our systems use extractive technique. So phrases or sentences in the summaries are exact sentences in the same article. But for the human-generated summaries, people had to construct their own sentences, and therefore, because Rouge scores are based on the patterns that exist in the article, it was difficult for the systems to perform as well. But that gives us the idea of what the system. We don't expect it to be as good as the other one anyway, but we notice these things here. Okay, so there are other things that we found out, and we discussed them extensively in the paper. For want of time, we will not be able to go into all of them. The key contribution for this work is, again, the data set, which we talked about, and the the summarization tool that is freely available. Open these links will take you to those places. In the data set, we have 513 articles. Indeed, for this kind of work, we probably need more, but because we really needed to pass them through human summarizers, and within the time of we have for this work, we had to balance the quantity of articles that we can get and process. And so we have 513, and they are accompanied by human summaries as well in this GitHub repository. Okay, so like I said, the work we've done now is basically extractive summarization. So the code and everything about what we have done so far will also be in the repository. So in future work, we will be focusing more on building abstractive summarization with more modern and state-of-the-art generative models, right? Such that we can use systems that are intelligent enough to create summaries that that are original, sentences that are original and not extracted from the text. And we have example systems like that: the BERT, the BAT, and the B5, and so on. So current effort that we're working on now is based on the multilingual C5, which also has Welsh, incidentally. Okay, so we thank the Welsh government and our colleagues in Ukraine and Cooking. And then thank you for stopping by.